So we're down to mobile device management frameworks. This is a big issue. As you know, these days, if you have a bunch of PCs, Microsoft is there for you. They have the server, the domain controller, and they have all these fancy features. So you can totally manage all your Windows PCs from one central point and sort them into groups and everything. And if you have Macs, you can use Casper to control them, similar to a domain controller. But if you have phones, you need to install some other mobile device management console to control it. And you've done this in the project. So there are different ways to do it. The fundamental problem with mobile devices is that you have the mobile platform, which is somewhat different than the OS on other devices, and you're limited by that. And the big issue is that these mobile devices are going to be lost and stolen much more than normal PCs. So you have a new threat model there, which is smaller with PCs. So as always, the first step in security is threat modeling. You have to define your assets, and you have to decide what risk you're worried about, and then implement appropriate security controls. If you don't do this, you end up with stupid security controls like the one where they make you change your password every 30 days. People have been recommending this for years. About 2 years ago, Microsoft did a study and said, you know, this doesn't make any sense at all. Why do you want to change your password every 30 days? Because you believe that someone steals a password and then waits more than 30 days and then tries to use it. Is that what you believe? Because I really don't think that happens. So what exactly is the point? And there is really no point. There's no evidence that doing that actually makes anyone more secure. All it does is irritate your users and not keep the bad guys out anymore. So anyway, threat modeling is a pencil and paper exercise. You just consider like this. What do we have? What realistic attacks are coming? And how do we stop them? And then you consider what your development team can do to limit that. If you don't plan this stuff, then you just respond to reports and squash bugs at random and don't really have any good security. There are a bunch of frameworks for doing this. Microsoft has been their software development lifecycle. They developed that since '99. There's an open source one called Trike. There's one from CERT. There's one from OWASP. I think Apostas from OWASP. And there's one from Cigital. There's a bunch of these, and they're all very much the same. They all have the basic approach like this. First, you diagram your app so you have all the functional units and you say what they do. Then you follow the assets. Here comes the useful stuff like credit card numbers and passwords. Here it goes, see where it goes. Figure out all the risks, rank the risks, and then start remediating the most important risks. This is just the normal kind of procedure that you should go for everything, even like physical security on the building and everything else. So here's a very common situation. You already have something like a bank, and you already have a website, and you already have users using the website from browsers on desktop PCs, and now you want to add a mobile device feature to the existing bank. So here's the game. You want to figure out what are the new threats coming from the mobile devices. So this is what it looks like. You've got the internet out here and your banking app and some other things here. You've got all these servers and everything working for your existing infrastructure. And now you're going to have smartphone users coming in using either the browser or the custom app on their device and coming in through the internet to your banking app. And now you can have a mobile facade doing here. And the idea is you don't give them full functionality. You have a mobile facade and it only lets them do a couple things up here. You don't let them just do everything. You choose what you want the mobile apps to use, and you realize they're a riskier clientele than the desktop apps. And so there's various places to attack. The bad guy can mess with the phone, like the owner could have rooted the phone, it could have a malicious app on it, things like that, or the bad guy could be intercepting the network traffic. Those are obvious places where you can get hosed, and you have to consider those risks and how they're going to affect your company. So people might hack your tools by reverse engineering a web app like we're doing on Android and such. They might inject code into the browser, or man in the middle the wireless connections, or put malicious apps on the phone, or use femtocells to intercept the telephone traffic, GSM, whatever it is, 3G, 4G. So the phone user is a risk because they might jailbreak their device and put on stuff you don't want. They might reverse engineer your device. Thieves might steal the device. This is why intelligent apps notice if your device is jailbroken. Detecting a jailbroken device is pretty easy. Another thing that I didn't even know enough to complain to all the banks and investment companies I investigated a couple of years ago is that I could run them all in a rooted Genymotion emulator. There is no reason to even allow a financial app to run in a rooted device, and you shouldn't. And you were just saying, right? You got to pay Google Pay, and it won't run in a rooted device, right? That's what should happen, right? They should tell you, look, this device isn't secure, but none of the banking apps do that. It's just appalling. They should have the highest security, and they pretty much have the lowest security. Yeah.
I tried it on Bank America. It wouldn't work.
On a rooted device?
On the VM.
It's in the homework?
Well, I mean, I just tried it to see if it worked. If I could load it, it wouldn't load. It gave me the warning.
What's the warning?
Rooted device.
Oh, really? So they finally added that in the latest version?
That one did anyway.
When did it happen?
I tried it like a couple weeks ago.
Well, that's awesome. Maybe they finally wised up, because I've been humiliating them for years. Yeah.
There's some more products available, framework products available now, because the Pokemon Go does root checking. Like it
Oh, good.
Root checking now.
Yeah.
So it's
Well, that's good.
more
Well,
available than at least in the banking apps.
well, I'm glad to hear it.
I think I loaded some other banking apps and they went on okay. I just remember which.
Yeah, well, Bank of America is the one I picked on first, and they got mad at me, and they contacted me and said, quit bad-mouthing us. And I said, are you going to fix it? And they said, no, it doesn't matter. And I said, well, then I'm going to keep on bad-mouthing you. So maybe 2 or 3 years later, they finally wised up. That's cool. I'll check out the latest version. That's good. It'd be nice if they would finally wake up and move from like the F level of security up to the D or something. It's very strange. So anyway, your users could do nasty things. The users could look at the source code and find the encryption keys, or reverse engineer the app, or do other obnoxious and stupid things, and you should consider that. There are other people that have some ownership and some stake in your device. The App Store account owner that you're purchasing things from might care about what you do. The app publisher certainly cares about what you do. They publish the app in the store, and they're ultimately responsible for it. The carrier has a stake in the device manufacturer, and the people that curate the store, like Apple and Google, and unfortunately Amazon. I haven't taken a look at Amazon in about a year, but when I did go through the Amazon Android app store, it was unbelievable. There's stuff there that's 2 and 3 years out of date. Nothing ever gets updated at all, as far as I can tell. And I thought it would be a handy place to get insecure old versions of apps for analysis, but it is appalling. It's intended for the Kindle, and apparently they don't have an efficient update process at all, or the developers don't care or something. And then, of course, your company's IT department that knows you're putting company data on that device, they have a stake in what you're doing too. So all these other stakeholders run the apps and the software. They want to control the credentials, and your carrier and handset manufacturers put apps on the device, and a lot of them are not really your friend either. They're reporting a bunch of data back. That's like Carrier IQ and other things. They may be improving the security or making it worse, and you may not have any control or knowledge of what they're doing. So there's just a lot of people messing with your phone and the apps, and each one of them has an opportunity to affect your security. The App Store curators are big ones. They have to have some system of deciding when apps are acceptable to put in the store, and some system for update and remove them. Like I said, the Android store seems to be essentially unmonitored, although Google is a little more better than it used to be. I remember one of the first apps I found there was the Spirit Airlines app that sent plain text credentials up to the Spirit web server, and you could log in and mess with your Spirit reservations. And so I contacted Spirit, and they said, we don't have an app. I said, well, somebody else wrote an app, and they're sending your stuff up in plain text. They said, well, that's not our problem. I said, that's one way of looking at it. This is not your problem. And it did, in fact, vanish from the store, so maybe they complained. Anyway, so one owner can do something another owner doesn't like the owner of your carrier wants to spy on everything you do, and now people are talking about your carrier tracking your clicks and selling ads. Now it's legal for them to do so, and it's clearly a revenue stream, and I must say I think that ruling is probably legally correct. I mean, Google is tracking what you do and targeting ads. Why is Comcast forbidden to do the same thing? Yeah.
I read that if you really want privacy, one article says you got to pay for it. Then you can be private.
Who do you pay? Comcast?
I just read an article.
See, you could pay a VPN provider, and then you're just trusting them not to snoop on
you got to pay the one that's going to sell the data. Otherwise,
right. So maybe Comcast could offer a feature where we don't snoop on you, but I think their PR department will warn them not to offer that. That would be like a bank offering an app that's actually secure for an extra $10. It would raise the question that you'd rather not raise. I remember when this all started for me maybe 8 years ago when I looked at websites to log into banks, and I found that they were all not HTTPS. And the only one that was Citibank. And I sent them a note saying, you should advertise this. We're the only secure bank, but they didn't go there. Nobody wants to go there. And in fact, they got hacked about a year later. So it's, They all want to just pretend we're all perfectly secure and we're not going to talk about it. That's what they think is fooling the regulators and their customers, and it seems to be largely true. Anyway, so each stakeholder has their assets, and users might like privacy, but the app publisher and the carrier want to collect information on who's using the app and what quality of service they're getting and things like that. So there's different kinds of data on your phone. One kind of data is data stored so you can read it offline. There's not too much of that these days, but there's some of that. Then you've got the personal data. Since the phone is intended to be owned by one person, you have people taking naked pictures of themselves and storing their contacts and voicemails and secrets on there, which they'd be very upset if it got out, not in a technical sense, but there's just embarrassment that their activities are exposed. And then you got sensors like the camera and microphone and GPS, all of which can be other problems. There have been quite a few series of DEF CON tools that will look through publicly posted pictures and track people because they're GPS tags, and you can find the secret hideaways of celebrities and who's sleeping with who and all sorts of stuff by tracking the GPS that they're accidentally leaving in the media that they post. And then there's identity data. And this is the more technical stuff. How do you know who is using the app? The actual login service is not tied to the phone as much as it's tied to the person, like Facebook. I don't really care what phone it is. I care which Facebook account to get in. So you've got to put some kind of identity information on the phone. And the best thing, you have some kind of credentials that stay there, and that might be the username. And the problem is there's probably also a token on the phone that counts for authentication, like a cookie. But anyway, one thing that was extremely popular at the time when we hacked the Apple Store was to just use the UUID of the phone as your sole authentication to get into services like Twitter. So once people knew the, or maybe it was IMEI, once they knew the unique number on your phone, they could just totally get in your account because that was convenient. But the manufacturers of the phone had always said, don't use this as an identifier, but everybody did. And then when we was able to dump them all publicly, that was considered a big deal because you could use that information to get in a lot of accounts. So anyway, another issue, of course, is your phone is typically the second factor for two-factor authentication. So if anybody steals your phone or is able to put a malicious app on your phone, then they can bracket your two-factor authentication now. So here's the threat model. You got to list your assets and stakeholders, try to figure out what risks there are, prioritize them, and then put up mitigations. And then you drive your secure software development cycle so the various security reviews target those things. Now, I must say it's hard for me to say this because I know this is all fiction. As we noticed, nobody actually uses OAuth. You know, there's what you should do, and there's what people really do. Even, I guess a few people do this, like Google and Microsoft and Amazon. The rest of the companies are just getting the cheapest developer they can get in Pakistan to make an app that looks good and not thinking about any of this. But someday they'll have to grow up to this. So I got a few iClicker questions. So which one of these is from search?
I knew which one's from OAuth.
I'm pretty sure it's Octave, which is the one that ought to have the octopus logo, but it isn't. The octopus logo is actually Trike, and Octave is the one from search. Okay. Which stakeholder is primarily responsible to keep malicious apps out of the Google Play Store? It sure would be nice if somebody would take responsibility for doing that. All right, and of course that is the App Store curator. Google is the only one that can keep the store clean, and they are gradually working harder and harder to do that. All right, which stakeholder is most likely to jailbreak the device? All right, the person with the incentive to do that is, of course, the end user that wants to put on pirate apps or forbidden apps or something. Nobody else has much of a reason to do that except a forensic investigator who wants to take the data off the device. All right. Which stakeholder is primarily concerned with the corporate data? I'm surprised we haven't had all these lawsuits. When Bring Your Own Device became popular about 4 years ago, I went to conventions and people were talking about this, and they said there would now be a flood of lawsuits as people try to investigate the evidence on phones, and people don't want their personal data exposed. And it's not 100% clear what part of that data is personal and what part is corporate property. But I haven't heard any big cases coming out of that. It is a big issue. If you mix your personal data and your company data on the same device, then no one understands who owns it or what rights anybody has. It's a screwy situation. Yeah.
The policy we had, it's our device, all the data is ours.
Where's that?
At a company I was working at.
All the data is yours, including the company data. So if you sell it and put it on pastebin, they can't prosecute you? I highly doubt that.
The corporation said, we provided the machine, all the data therein.
That's right. That's one way. They give you a phone and it's 100% a company phone. But what happens is people bring their home device and use their home device to do company work. Just like Hillary, they don't want to carry two devices. And almost every company allows that. And the legal department has been complaining for years, when somebody does something bad, you're going to be sorry you did that, because now we really don't have the right to examine that data. We're going to have a whole battle over whether that's really a company phone or not. That's what would be right. That's why another thing, self-employed people, they have trouble with their taxes because they have a car and they drive it for personal stuff and they drive it for work. And like the tax people say, you should have two cars. Then you would, or if you don't have a clear separation, it's going to be real hard to justify what you claim. Having two phones is the most happy solution for the legal department, but most employees are not willing to do that, especially the most productive, high-end employees have no interest in that. They want to use their device, and they want you to just cope with it.
Well, they're going to put it buried in the terms of service. Here's sign here when you enjoy it, when you are employed in the company. You already agreed to do this.
They can try that, but I think they're worried that it won't hold up in court. Like if the device is really your home device that you paid for yourself and it's mostly used at home and you had it before you joined the company, then you would have a pretty good argument in court saying they don't really have the right to suck the data off of here, even if you signed something. That's why, but your answer is the right one, an air gap. There should be a company phone and a personal phone. That would be the way to keep it clear, but nobody bothers with that hardly. And sometimes they're sorry, like Hillary. Anyway, so anyway, did I grade this one? I did not. It's the IT department of your company, of course, that cares about the corporate data on the phone. Let's see if we have more of these. There is another one. Okay, which data type includes your GPS coordinates? It's surprising how few phone hacks have been. I remember like 5 or 6 years ago, all the security experts, DEF CON and stuff said, we're going to have waves of phone malware and everything getting hacked because it's so juicy. You could turn on a camera, you could turn on a microphone, you could totally invade people's lives, and yet there's not a whole lot of that happening. Anyway.
Yeah.
I think it's kind of like Y2K. All this complaining and attention has had some effect of focusing people trying to secure them. Anyway, that's of course the sensor-based data. You're now carrying a bug that records all the sound around you and pictures and your location and sends it up to a server. Is that me?
No.
Oh, you're good. All right, fair enough. Anyway, well, I think it was me earlier. All right. Now, anyway, let's see what time is. Good, we can carry on. So, secure mobile development. Here's the main plan. Your mobile client is the app on the phone, or perhaps just a browser if you just use a web app, and then you have the services at the other end, and both of them can be attacked, and both of them have assets. So you have to threat model them both. There are two general ways to do it. One way is to use the native API for the phone, which is either Android or iOS, and use the built-in functions you have to get the full value out of the phone. And if you do that, your developers have to learn that environment and write it custom for the phone, and you would look like the other apps on the phone and meet the user experience expectations. But if you get tired of that, another opportunity you could do is just open the browser. Just make an app that does nothing but open a browser window and connect to the website, and then have it all done in the web. And then you're actually not using much of the phone except the browser, but it's a whole lot simpler for your developers. And now you can have the same app on both Google and Android and iOS without bothering to do anything, because you're really just connecting to a website. So that's another way to go. And there's cross-platform mobile development frameworks that try to make this easier, so you try to get the best of both worlds. So you have some code running on the device a little bit more than a browser, but it's all written in something like JavaScript that's universal. Anyway, the next issue is how do you make sure that the OS is in its intact version? And as we're saying, now it is very easy to just put a jailbreak detector in your app that lets it refuse to run in a jailbreak device, and that would be nice. But how do you know if the app itself has been modified? And we talked about this before. You can put in app integrity protection The most expensive product is ArcScan. I hope it's the best. They don't have a free trial, so I can't test it, but they claim they have many layers of integrity control and encryption, so nobody can realistically mess with the app anymore. And that's the point. You have to put in some kind of integrity protection to prevent that. And you also can have the mobile device management system, like the one we tried before, the IBM one, where your boss can actually see what you're doing at the phone, and that has some ability to detect jailbreaks and whether you're messing with the apps. None of them are perfect, but they give you some assurance. So if the device is jailbroken or rooted, then you could have an app or modified OS that lies and claims not to be modified, and certainly that's possible. Your mobile, there's also there's mobile device management, which we looked at before. That's the IBM product that gives the boss complete control of your phone in principle, although you can choose how much control to give them. You can have a weaker thing, mobile application management, where you don't try to completely control the phone. You just want to control application provisioning to make sure that they get the official company app from our official company store and it's not modified. So that's a milder, a less strict way to control things, where you say the only thing I really care about is this one app. I want to make sure it's intact. Anyway, of course, you'll have your own app store, and that's where you're going to put on updates and patches. And so here's guidelines. You know, you have normal web app security you have to put in here. You should have a walled garden for mobile access, so people coming in from the mobile app cannot get to all the resources at your servers because you can't trust them as much. If you use JavaScript, you should use a secure subset. We'll talk more about this later, but JavaScript has some dangerous methods, just like C does. Microsoft, when they decided to take security seriously, they modified the C language by blocking a bunch of the really dangerous functions like string copy and changing some environment variables and such, so that it would, some global parameters, so it would be safer. And they published that, and there's a way to make JavaScript safer. If you're going to store sensitive data on the device, the best thing is don't, but if you have to, then you're going to have to either put it in the secure hardware, like the secure element, or encrypt it and hide it. You authenticate to your mobile services. You've got the usual stuff there. Your protocol should be encrypted. You should be using SSL and TLS, and you should actually use it instead of turning off the certificate validation. And it's a very good idea to use certificate pinning. I haven't yet found any app that does it, but that's what everyone should be doing, where you not only verify that the certificate comes from a trusted certificate authority, you verify that it comes from the right certificate authority and no imitations are accepted, and then even nation states can't fool you. If the government of China signs that certificate, your app will know this is not supposed to be signed by China. I'm not accepting it, even though that's on the list of trusted certificates. It's simple enough to do, but nobody much bothers. All right, and there's, we'll talk more about these other threats. You've got a caches, and you've got logs and a clipboard, all of which can leak data out by leaving extra copies of data in places where you didn't intend to store them. And then you've got coding guidelines for your application-specific, your iOS ones. You're writing in C, and there are some things you do to make C safer, and also Android. There's some things you can do to make it safer to use the more modern defenses like ASLR. So that's what these go through in some detail. Normal web app security is the OWASP top 10 that you know from other classes. Code injection and insecure direct object reference and things like that. Since you've got a web server and you have requests coming in from the mobile device, you can make all the usual mistakes on the web app. The walled garden is limiting what the mobile devices can do to whatever they need to do and not giving them the full functionality of your server. This is another one of those recommendations that sort of irritates me because I know no one's going to do it. They want you to have timeout on the mobile devices and make people log in. The book keeps saying this. Nobody does this. Anyway, that's the idea. And here's the secure JavaScript subset. There's an eval in JavaScript, which lets you, I think, evaluate command line commands. That's what it is in Python and in PHP. And I'd say if you system, and there's square brackets and this, these are all things that make it possible to inject code. So they should be blocked, and there are some defined JavaScript subsets that remove the most dangerous functions, which is a pretty good idea. And their square bracket is one of them. There's this square bracket you use like this, and I think if the user input is able to add more square brackets, they can make this do anything. Open a command shell and affect other objects on the system and such. So it's too dangerous to allow, and you should use a subset that doesn't allow those dangerous methods. If you have sensitive data on the phone, you can mask it or tokenize it. Rather than storing a password directly, you could store some kind of token like a cookie, or you could store just part of the data, masking part of it with stars or something. These are ways to make it less dangerous to store sensitive data on a untrusted device. In general, this is a bad idea. Here's the strongest to weakest places to put sensitive data. In the security hardware, like the secure element, is of course the best place to put secrets. If you can't do that, use the platform's secure storage, like Apple's Key Vault, and Google has whatever they have in Vault. And that one, I think you were telling me now, it works by actually storing the encryption key on the SE and then using it. Somebody was telling me that. So that's just a pretty good plan, almost as good as being on the SE, although a lot of Android devices do not have an SE, so this is not an option, and this is the best you have. And then you can put it in mobile databases or in the file system. Those are less and less safe places to put it. In principle, even just storing it in the file system should be safe because supposedly each app is sandboxed from other apps, but in practice there are often errors that defeat that, and you'd be a whole lot safer to put it in a better place like the secure element. Your personal data is all over the thing. I mean, the main issue of these things is to be a good camera and such. You've got that on there. You've got the sensor-based data, and you've got identity data. Usernames and other things stored on the phone, and all these things are assets you have to protect. So the secure element is the safest thing. This is a cryptographic coprocessor that can do encryption and store keys that can't be stolen with any app on the processor because they do not have the memory mapped into the processor address space. All the processor can do is ask the secure element, please decrypt this stuff. It never gets to see the key, which is pretty good. And it locks out after a certain number of pins, so you can't even try to brute force the key and so on. The only problem is they reserve the secure element for use by the manufacturer, not by third parties like your bank. So here's MIFARE, is another one that has a card-based system with 48-bit key, and there's quite a few vulnerabilities in this. There's a similar system that meets a certain standard, but it has been found out to have quite a few vulnerabilities by the MIT researchers. Then there's Apple Keychain. This is a SQLite database, but it's protected by a layer of encryption. And so you can only open keychain items by the app that stored them and other apps from the same developer. But the root user can read the whole keychain, and I know Duffy was always sneaking up to my computer trying to dump out all my passwords at this thing. You can just do it from the command prompt. You can dump out all the passwords in the keychain, which is pretty cool and not so great from a security point of view. Yeah.
There's a pen testing commodity kit called Empire that has a keychain stealer, local account fisher, and then keychain breaker modules all included in that. And you can look it up on GitHub if you ever want to break into Apple.
That's great. And what's that?
Empire.
Empire. Let me see if I can bring it up and put a note on the website. That's a good thing to know. Empire.
It's with the Y. That one's the PowerShell version with the I. The Y is the Python one.
All right. Let's see what I find if I Google that.
Add GitHub to that.
GitHub. You go to GitHub down here. It was like right there. Need a post-exploitation. So first you have to get root on the device, though, right?
Well, I mean, it's got a phishing kit built in, so you can try to fish.
Cool. Okay, well, there it is. Actually, I'm not using my home computer, so I can't add that to my website. But anyway, it's good to see. So Android has their KeyStore to store cryptographic keys. It doesn't have any inherent protection mechanisms, which is not so good. So apps would have to provide a mechanism. Now, the recommended way to do this is to take a password and then generate an AES key from the password and PDKDF2. All this does is like 5,000 rounds of hashing with something like SHA-512. And it might add a salt. That's the general way you create a key out of a password. That's the recommended procedure. So your mobile database can be encrypted with a secret, and then you have taken a whole bunch of sensitive things and turned them into one sensitive thing, which is now the secret, which you have to store somewhere. One thing to be aware of is even innocent data can get you in trouble. AOL found this out about 10 years ago. AOL just published search histories from people without their names or IP addresses, thinking that that had been anonymized, and people rapidly found that the search history can trivially find anybody because almost everybody searches their own name and stuff and their own address. And so you have to watch it. Even very indirect things could reveal secrets about someone. And these databases can, of course, be attacked with SQL injection and other attacks. You got file system in iOS. Each app has its own portion of the file system. and it's linked not only to one app, but also to a specific device. So if you copy a file from one device to another, it'll become unreadable. And that's a pretty good idea. So, I mean, Apple has quite a few layers of encryption. I know Thomas was talking about his work developing a new jailbreak, and it is really amazing how many layers of encryption and keys are used in Apple firmware. Yeah?
I was just reading today for iOS 10.3, they're pushing a new file system.
Oh, yeah, I've heard about that. A new Mac file system. They said it happened silently and didn't break anything, which is, I know, I'd like to know what the difference is.
Well, a lot of it's security concerns, so I'm interested too.
Yeah, and I think next week or maybe the week after, Thomas will be here to show us his new jailbreak. He's released the code like 2 or 3 days ago. He's made a new jailbreak. It only works on older phones, but it uses a new technique. So there's a group of phones that were not jailbreakable before, and now they are because he invented a new jailbreak. And then he told me about it, and the one thing I noticed was he found an exploit that lets him write 1 byte of 0 in RAM. And I said, you can't do much with that. And he totally took over the phone with that. And that's pretty impressive. Anyway, so files stored in internal storage are private to the app that created them by default permissions. But if you change the permissions to world writable, world readable, that makes them accessible to everyone. And if they're on the SD card, that's the default. Android 3 does have the ability to do file system encryption, but very few actual hardware devices do it because they're worried about battery power. I think the latest ones do, but not all of them. Google keeps on promising to make encryption turned on by default, and it keeps on not really happening. At least as of 2015, it hadn't really happened yet. Because it keeps on draining the battery life. That was my problem with Android phones. The battery life is just terrible. And I certainly wouldn't have appreciated having a default feature that sucked even more battery life out of it. Anyway, all right, so which one of these annoys the end user and is therefore almost never used? All right, and that's, of course, session timeout. That means they have to type in their password again, and since they're using a miserable little keyboard that doesn't work very well, they really hate making the user do that. All right, which one avoids square brackets? All right, that's the JavaScript subset. Square brackets in JavaScript are evil. All right. Where's the most secure place to store your data? All right, and that's, of course, the security hardware. So if you use Apple Wallet, it really is considered quite secure. People say it's safer than normal credit cards. I don't know if that's true, but it might very well be. Where's the...
Your card every time.
What's that?
It virtualizes your card every
Right.
time, so it's a different number for each transaction.
Yeah, which seems like a big step forward. Yeah. So what's least secure? The new chip system, I think it might also use a different token each time, but I'm not sure.
Well, but it's supposed to use a PIN each time too. And
Well, he doesn't have the PIN, which is why the American version of it is not that secure. But I think at least it has a different token each time.
that's why it makes it seem like it takes longer too, because it's expecting you
Yeah.
to type in your PIN.
Yeah. Anyway, this is the least secure place is the SD card, which is not only removable, but everything put there is world readable. What's the most secure place that a banking app can put data on your iPhone? A third-party banking app that is not from Apple. All right, the best thing they can do is use the Keychain, which is secure platform storage. They are not allowed to use the secure element. So they have to go one step down. All right, so then you got your mobile services. As we talked about before, you should use OAuth so you do not have to handle passwords, but you just get a token that's of less value than a password. And you can use SAML to specify your security condition and move it back and forth to the server. Very few developers seem to care, but these features are well developed and available for someone who actually cares about security. When you have an identifier, this is a huge issue everywhere. I mean, the college got in trouble, everybody got in trouble for using social security numbers for identifiers. And most people have learned the hard way that you should just make up a number just for your company. Like the college gives you a W number, everybody gives you a number, because if they use anything else, it turns out to be a mistake. It's either predictable and guessable, or it's private and it enables access to other things. So if your device is stolen or sold, then the identifier is still on there. Now, in the past, they would use things like the MAC address, the phone number, the IMEI, which is just sitting there and awfully handy because they really cared about convenience. And if they just read the number off the device, then you never have to log in at all or have a password or anything. They know who you are. And as long as nobody ever loses their phone or gets a new phone, this will work. But when phones move from one person to another, you'll be sorry you did it that way. So that's an issue. And also those things leak out. So you should have, always generate your own identifier that isn't connected to other things. Have a timeout for cached credentials so your cookies actually expire sometimes. This would be a lot safer, but nobody does it. Use TLS, of course, and actually validate the certificate so you're using full TLS, not some broken implementation of it. If you make direct communications directly to HTTPS, you can't even get in there with SSL strip. The only reason SSL strip works is because you go through HTTP and get a redirect that sends you to HTTPS. And so you should be doing certificate pinning. Certificate pinning means that the app knows not only that the certificate should be valid from a trusted certificate authority, it also knows more about it. It could even know the serial number of that exact certificate, but that's irritating because every time your certificate expires, you have to update the app. So what most people have settled on is it should know the public key of your trusted certificate authority. So it's like VeriSign, and I'll only take VeriSign keys. That's a pretty good compromise, which makes it even stronger than normal HTTPS. And there's no reason not to do that because the app could totally be built with that information. It's just something the designers have to bother doing. This is similar to what Google has now put in Chrome. Chrome now knows the top 1,000 websites and whether they should be secure or not. So if you type Facebook in the Chrome and press enter, it makes an HTTPS request to Facebook. It does not try to make an HTTP request first. It knows that Facebook should be secure. It doesn't waste any time doing the risky HTTP request. And that's a little bit like certificate pinning. That's like what HSTS will do. It's a step towards a secure web where you don't bother with these untrusted connections at all anymore because it's getting too dangerous out there. I know it's happening because in my projects, you remember when you're testing a browser, I have you go to AOL, and halfway through the semester, AOL became secure. I can't find a popular website much to test it. The only website I know that is common and still insecure is Bing, and also one of the Microsoft ones. Everybody else has encrypted everything, even Wikipedia. Yeah.
I was just going to say MSN is my go-to, msn.com for an
Yeah.
encrypted website.
Yeah, and also Bing.
Yeah.
But it can't be too long before the penny drops and they encrypt their stuff too. But we'll see. Anyway.
Left it up for testing purposes.
Yeah, I'm probably going to have to start sending people just to my website. But it's going to stay insecure long enough for projects to be done. All right, so WebView is the engine used to display web pages in the browser. And it, unfortunately, has caching. And that is not controlled by your app because it's in the browser. So you could easily end up with sensitive things like passwords being stored and in autocomplete in the app. So, and the cookies could be used to get into other websites. So the wise thing to do, you can specify in your web page to not use autocomplete on the forms. And you can set the no cache header on the server, which if the browser is acting correctly will mean it will not cache any content from that website. So if you think about this, you can do it. You can also use clear cache on Android. Unfortunately, clear cache doesn't work. It doesn't get them all, and you have to go specifically figure out what to delete and delete it. It's more irritating. But anyway, that's one thing about going through a browser. The browser is caching things. I know in my practice, I keep updating my website, and I always find that if I go to Chrome, I still see the old version, and Shift Refresh does nothing, and clearing the cache does nothing. It stubbornly caches stuff, and I have to go to a different browser to see the new version. This happens a lot. Caching is very vigorous in modern browsers, and it doesn't seem to obey any of the rules that it ought to rule. A refresh ought to cancel it, but it doesn't. Anyway, session timeout would be a good idea, so stolen cookies don't just stay valid forever. Like I say, this is recommendation, but I never see anybody do it. Then there's JavaScript bridges. We talked about these before, where you have these JavaScript frameworks that let you write your whole app in JavaScript, so it'll be cross-platform. It saves your developers a lot of time, and there are some rules to make it a little bit safer. In general, it's considered pretty dangerous. But if you use a more secure version of JavaScript, it's better. If you use a custom URI scheme, like something colon, like tel colon for telephone numbers, then be aware that that can be exploited with the techniques we talked about in the last class, and you've got to be careful to expose that as little as possible to other apps and filter the input and output from it because it might be malicious, attempting to inject things. And then there's information leakage. The other ones are talking about design flaws where you deliberately put data where it shouldn't go, and then where the browser makes extra copies of data you didn't intend. And there are other things out there that are making extra copies of the data, like the clipboard. Now you can copy and paste things. If you do that, the clipboard is stored somewhere on the phone, and that's not secure. So you can turn off clickable on a field so it can't be copied into the disabling copy and paste, which is a pretty good idea, so people can't copy and paste passwords. Of course, this means they can't use a certain category of password managers, so some people will get mad. You actually have to type in your password, and if it's long and complicated, that's annoying. And you hit the very serious problem with most of these recommendations is that they make it more unpleasant to use the app, and therefore, for marketing reasons, they will not let you do this, because your app will annoy the user more than the other app, and people would rather have less security and more convenience. And then there's logs. Like I say, both the normal system and the debug logs might have sensitive information in them. And the logs are public. Any other device can read the logs, so if you're putting secrets in the logs, you're going to be sorry. This has happened over and over and over, that either intentional code that the developer wrote or code in the operating system logged something sensitive and leaked out information. And so iOS specifically, it has a keyboard cache, which is there so that it can have that notorious autocorrect that everybody hates that keeps changing your words. That's the local dictionary, and you can reset the dictionary in yourself, but if you don't, then words you type in end up in that dictionary, and they may end up auto-completing, so your password might auto-complete in an IM or something, and then you'd be sorry. Address space layout randomization is not always on by default. When you compile your app, you may have to specify explicitly that you want this to be there. Make a PIE app, position independent executable. If you make a custom URI scheme, like Skype did, it's the same old story. Be aware that you are now taking requests from other apps, and they may be malicious. They may be attempting to inject special characters and such. The stack needs to have stack smashing protection, and apparently you have to explicitly request it sometimes, but the Apple compiler will do it by default. And there's this other thing called automatic reference counting. And the point of this is it somehow keeps track of how many memory regions you have allocated and makes sure they all get freed when you're not using them anymore, so you hopefully don't have use after free vulnerabilities. It sounds pretty good, but apparently it's pretty dangerous and it breaks some code. So people don't love it. And then the application screenshots, I was just amazed when I heard about this. In order to make the animation, when you close an app where it shrinks down and the other app comes up, they store an image, like a ping image of every screen, and keep it where it can be stolen. So they're like, it's a visual keylogger. They're keeping track of what you've been doing in images just for beauty of the interface. So that's sort of gruesome, and you can prevent it apparently by having a splash screen so you have something else there's no sensitive information on it which actually gets shrunk down. But this is, I think, the first example that really got struck home with me of how to make it easy to use and fun, they drastically lower the security. Yeah.
Notice my Capital One app now blanks out the screen. Like most of the banking apps and stuff don't, so you can see your balances and stuff in your app history.
Yeah, so when you close it, it blanks out the screen and then closes, right?
Yeah, well, or when you go into your app history, it shows you all your running apps.
Yeah.
It'll show a screen capture of those running apps.
Yeah.
And yeah, I noticed recently they updated that where it has like a panda or something on it.
They did something good, like just put the logo there or something. Yeah, that's what you should do. That's good. People are very, very slowly learning some of these things. This is a pretty old book too, you know. Most of this stuff is from like 2012, 2013, but app designers are still mostly not getting the memo. Anyway, in Android, they recommend using Java rather than C++, which is certainly what most people use. Now, the point there is you don't control the details of the binary code. it runs in a virtual machine, and the virtual machine presumably has ASLR and all that jazz, and you don't have to worry about it. But if you are going to write C and C++, you have to make sure you have position-independent executables that can be relocated in memory, or they will be subject to the old-fashioned buffer overflow attacks. And the intents are the signals that go from one app to another on Android. And again, the rules are, be careful. Anytime an intent comes, you should scrub it for special characters and consider it might be malicious. And you can limit it with signature limitation to only accept intents from your company's apps, and otherwise limit which intents you accept. And don't put any sensitive data in intents, because they go to other apps and they might leak it out. And NFC, of course, one big problem with NFC is you can't trust the data in the tags. The tags can be maliciously altered, so you have to have input validation on your NFC reader to try to detect malicious content. If you do write tags, you have to remember to write them and then write protect them so they can't be changed again. All right. So which item can make your app more secure than a browser? This is what I expected the financial apps to be doing. And that's certificate pinning. That would be more secure than your browser. And there is the perfect opportunity, because the company totally knows what server you're going to be connecting to. They could very well put information about the certificate in the app. They just don't. It's a sin and a shame. They can't do it in a browser because you surf the whole web in the browser. They don't know where you're going. But the app totally knows where it's going. All right, which one can leak the password out of a browser? All right, and that's the cache. Various caches, like keyboard cache and such, can have information that then leaks out. All right, where's the safest place to put a password? All right, and that's HTTPS is the only thing on that list that's any good at all. The rest of those are miserable places to put a secret. All right, so which one can leak secrets and is done just to make the app look prettier? Of course, to be fair, looking pretty is really important. Customers really appreciate that. And that's those cached screenshots, part of why everyone loves their iPhone. It's beautiful and fun to use. This is one of the many reasons why it is beautiful. All right, which one improves C, but you don't need it for Java? All right, and that's ASLR. You don't need to think about it when you write Java because the Java virtual machine does it. You're writing at a higher level. In C, you have to consider it when making your app. So I'll see who got the most right. And I should also mention, I plan to have a demonstration today, but it's not ready. I decided I'd quit waiting for Staples. I told Staples around the new year that their app was appalling and encrypted data with a predictable key in electronic codebook mode. And they told me they were going to fix it. And they did nothing, and 3 months later I said, when are you going to fix it? And you don't even answer me. So I'm just going public, and I'll have homework for you. But they did modify the app in the meantime, and it's kind of irritating me. They didn't fix anything, but they changed it so that APK tool isn't working very well. So I'm hoping to have that, because you can learn some good tricks about encryption. I'll try and write that up as an extra credit project. But I think there's no more, I'm not planning to add any more official projects. Let me just mention that. We're getting to the end of the semester. People might be worried about grades and stuff. So it would probably be good to discuss that for a minute. So the projects go down, I think, just to Project 13. And if you look at the schedule, that's pretty good. Project 13 is due a couple weeks before the end of class. I don't think I'll make another required project. Anything more will be extra credit. And I did cancel this class. I'm going to go to a conference in Washington, D.C. They approved me to talk there, and I'll give it a shot. Anyway, just wanted to make a couple scheduling notes like that. And let me see who won the iClickers. So I'm hoping to have that project where you hack into the Staples app next week. I just have some obstacles that are holding me back. And I'm hoping to solve them. I may also find a more advanced tool than APK tool. There are a bunch of other Android reversing tools, and I'm hoping that one of them might do a better job on the new app. But the ones I've tried so far weren't making anything any better. If anybody has any ideas, let me know if you know some newer Android reversing tools worth trying. You can go get the latest Staples app and try to, if you take the Staples app and decompile it with APK tool and try to build it again, it won't build. You just get a screen full of errors. And the last time that happened to me, the cure was to update to the next version of APK tool, but now I'm at the latest version. I could try building it from source, and that would get me a more later version of APK tool, and that's one possibility. The other thing is to try to find a different tool to use that might be more modern. But the first one I tried, in fact, was just using APK tool anyway. It was just like a graphical front end for APK tool, so it really doesn't fix anything. Anyway, I'll let you know, whatever I come up with.
That's not
They have master fingerprints now that'll unlock 5%